And somebody left the building. OK, it's time to start then. OK. OK, I think we are ready to start. So, yep, OK. So hello and welcome to the Nokia extensibility session. My name is Lucian Tomuzza. I work for Nokia Developer Experience, a team that focuses really in making your life easier as much as we can, helping you develop for Windows Phone and giving you more opportunities to do so. We are going to talk today about Lumia. Not necessarily the products that you're seeing here and you all know, but what you do on top of them. As you can see here, and as you probably have seen in the announcements in the keynotes, our Lumia range is growing. It's growing towards the low end, where we have very affordable products, and it's growing towards the high end, where we are adding new and new features, making it more rich and powerful. Of course, from a developer's perspective, the advantage is that you're looking at all these as one platform. It's all Windows. We have also the Lumia tablet. Now with Windows 8.1, that also becomes part of the family. You can develop one application, deploy it everywhere. And you have seen these days talks about this from the colleagues from Microsoft. So it's very good for you as a developer, I hope, and I believe it is, to develop on these devices. You have access to rich features, and at the same time, you have a wide platform to develop and deploy your application to. Now, we are building very good hardware, and we are using the Windows Phone operating system to provide the baseline user experience. And this ensures that even on our low-spec devices, we have very good quality. We have smooth user experience across the device range. On top of that, we want to build even more. We want to create differentiation. We want our product to stand out. And there are a couple of areas and technologies in which we already have the assets that enable us to create this differentiation. For example, imaging. I think everybody knows that when you're talking about a Lumia device, you are talking about a very good camera application, a very good imaging story with applications like Cinemagraph, Nokia Refocus, Creative Studio. There's a lot of work being done by Nokia to achieve that and to create those applications. Similarly, we are doing work in location, where you, I'm sure, know the Here suite of applications, Here Maps, Here Drive. We are doing similar work in music, where we have the Mixed Radio application, which is an excellent music application, right? And offers you a catalog of 30 million songs to listen to for free or for a very small fee. And now we are also developing in the area of context, letting the user know and discover themselves and how they behave in the day-to-day life and trying to improve their life with that. But while we are doing these investments, we are always thinking about how do we enable this for a third-party developer. Can we build not only good applications, but also good APIs for you guys to use? And we have APIs in all these categories. We have good APIs for mixed radio, and they are evolving all the time. You should really check last year's talk at Build on the subject, and check out the website for the new releases on the API. We have very good location APIs, which are now integrated in the platform, so you can easily use Here Maps data within your application very easily and without any data transfer cost. And we have, as you probably know, the Nokia Imaging SDK, which is one of the areas where I'm going to focus today. And I'm going to show you how easy it is to use, the feature it has, and also tell you a couple of things about the new features added in the latest release, version 1.2 beta, which we just announced 2 days ago. And also, we have now to develop in context, and I'm going to show you what we are working on in that area. OK, it worked. So Nokia Imaging SDK. How many of you actually know the product? OK, good few. The Imaging SDK Oops, I think there's something wrong with the slide, but let's go ahead and see what happens. Sorry? You cannot see them? Ah, it's OK. OK-ish. OK, so the Nokia Imaging SDK is really, like I said, our attempt to offer you some of the features that we are developing in-house for our internal applications, make them available to you as an API, easy to use. And then, of course, in time, we also start to use it as a base for our products. So we are eating our own dog food, like, for example, with the Creative Studio application, which is now adding filters in their application based on this SDK. So what the SDK is offering you as a very base kind of set of APIs is to start with 50+ filters which are ready to use. So if you are developing an application which relies on modifying captured images and applying filters to them, you have here the building blocks for something like that ready-made. If you're not happy with what we are offering, and trust me, there's a good range of filters there, you can still create your own. We offer you a very easy extensibility mechanism so you can create whatever you desire in terms of effects and filters to process your images. You can use these APIs from native or managed code. Depends on how you prefer to work with it. And yeah, it came back. We give you easy ways to, or easy mechanisms to take in sources, basically from any possible image source. So for example, files could be very easy to access, local files. Or if you have an image received as a stream from somewhere you're downloading, that's also very easy to just plug into the SDK. If you're working with a camera viewfinder and you want to modify on the go or in real time the viewfinder image, we have an easy to use API for that as well. And of course, in terms of output, you can put kind of generate your modified image and save it in any format you want, be it as a bitmap, uncompressed. You can save it as JPEG. You can save it as PNG, whatever you want. It's very flexible. You can put data in, modify it, and take that out in three moves and 3 lines of code even. All this is based really on a very powerful technology that Nokia has patented, the random access JPEG technology, which gives you very fast access to any part of a high-resolution image. You can load it as fast and as memory efficient as any of the native applications do it on a Lumia phone. You can rotate, you can apply lossless transformation to the image, and all that is done really, really fast with a very low impact on the phone's resources. We have released this SDK less than a year ago, and since then we have done several updates. In February, we released version 1.1, which brings new filters, new capabilities, and also brings support for the big windows. And now with release 1.2, which we released just 2 days ago, as well as adding new features, we also added support for Windows Phone 8.1, which means that now with this release 1.2 of the SDK, you can basically develop cross-platform applications, target either big Windows or the Windows Phone with the same code and the same set of features. Now, in terms of what's new in this SDK, rather than the support for the already mentioned support for Windows Phone 8.1, we have a couple of new filters that you can easily apply to your images. First, we have an improvement to the blend filter, where it's now possible to specify the target area for the image that you want to blend on top of the background image. We have an image aligner API, which is a nice tool for stabilizing images when you want to create an animation. So if you have a shaking hand and when you capture a sequence of images, with the image aligner, we help you remove this shakiness from the set of frames. Then you can use these frames to create, for example, an animated GIF, or if you just want to create a standard GIF with only one frame, that's also possible with a GIF renderer. And we improved also the performance of the custom filters that you are writing so that now you can actually use them with even lower memory consumption, so you only receive small data buffers to modify in your filters. I was talking about filters, and like I said, there's many of them, as you would expect, and if you have any experience with any image editing software from the PC world, most of the filters you expect to be there built-in, they are there already in the SDK. Low-mo filter, negative, cartoon, all kinds of them. You should not look at them as just prefabricated filters that you are ready to apply to an image, but you should think of them as building blocks, because mixing them together allows you to create new effects, allows you to be more creative and create something that's unique to your application. And with the imaging SDK, it's very easy, and we will see that in the demo immediately. It's just one more line of code, and you add one more filter to a pipeline, and then one more line of code, and you render it. And here's an example of a very powerful effect. You can mix together two images, just specify which color from the source image to be ignored or made transparent, and then when you blend them together, you create a nice effect and move your subject in a totally different world. And if you've been to our booth today, you have probably seen the space selfie demo application, which is utilizing precisely this effect to create a space selfie effect. You should really still try to give it a try if you haven't. We are still there with a booth. And another powerful tool that you should remember that there is in the SDK is the blend filter. You can blend together two images, and that's very simple and obvious, but remember there are 15 ways to do that. So if you just start with an image, and you start with a standard gradient image that you may generate on the fly with the imaging SDK, by simply changing the function with which the blend effect is applied, you have 15 ways to generate 15 type of effects from just mixing those two images together. Again, if you think about putting those in a stack, several type of effects created based on this blend filter, and you have, again, a very powerful and flexible tool for you to create new effects for your application. The architecture of the SDK is very simple. You have several built-in components, starting with the image source. Like I mentioned already, there are several types of image sources that you can use, depending on where your image comes from, whether you have a bitmap or you have streams or files on the file system. You load them very easily with those image source objects. Then you chain that and provide them as source to a filter effect, or more than one if you chain several of them, one after another. The output of one effect can be the input on the next effect. Or you can mix different sources as input to different effects and then blend them together at the end before rendering. Finally, at the end of the pipeline, you should have a renderer object, which has a very important method, a method called renderAsync, which is the one that drives the entire pipeline. So you stack everything together, one by one, starting from the source, the effects you want to add. At the end, you call the renderAsync method, and that does all the magic. Once you have this stack created, you can always change the parameters of the filters. You can tweak them. You can allow the user to change different parameters to customize the output. And then you just call again renderAsync if needed, and you have a new output generated. You have full specification, of course, and full documentation on the Nokia developer website. And it's time to do a quick demo, just to show how easy everything is. OK, so first we need to find the SDK and install it. We're adding it as a Nugget package, so just right-click on References, Manage Nugget Packages. And we search for Nokia imaging. OK, this is taking a bit of time. OK, we found it, install, couple of clicks. And we are almost ready to go. Yep. We have a README file. You should read it. Now we don't have time for that. There's one trick that you need to know, the fact that we have a native library doing all this magic work, so we don't support any CPU configuration, which you may want to remove from the project. And at this moment, you are pretty much ready to go. There's a little bug in the Visual Studio, and you may need sometimes to close the solution and reopen it again in order for the references to load correctly. Let's see. Yes, now we have the Nokia graphics imaging components loaded into the project. And here I have a simple project in which I use the photo chooser task to basically load an image from the gallery and then apply a filter to it. As you can see, I already applied or show the image on the screen using this image component. Oh, no, sorry, it's the original image component. And then now I have to apply the SDK magic. So let's see what I'm doing here. First, I'm loading an image, which I have in the resources, this mixed radio PNG. I load it from a file, so I use a storage file, image source, and it's as easy as that to get it loaded. Now, I need to tell the project where to look for these classes. Isn't Nokia graphics? OK. Now they know about them. Then, because the image I selected from the photo chooser task comes to me as a stream, I use a stream image source component to load that file. So I have two files to work with now. The next thing, like I said in the pipeline, is a filter, or rather an effect. And in this case, I'm using the effect filter, which on its own can contain many filters in a list. I'm using a writable bitmap renderer to generate the output as a bitmap so I can display it on the screen for preview. And I'm using here a JPEG renderer to generate or to compress the image as a JPEG and save it to the disk. So all I have to do now is create or generate a list of filters to be applied to the image. And I'm using the blend filter here. I just instantiate it. The blend filter basically puts two images together, one on top of the other. The background image is going to be my source, the one that I selected from the gallery. I have to specify here which is going to be the foreground source. And I chose that to be the stickers of the source that I loaded from the file. And now I add it to the list and say that, OK, you filter effect, use these filters from this list and apply them to my image. And then I just call render async on the renderers to generate the image with the effect applied. And this should work just fine. OK, now we have a problem. Does anyone remember where this extension is defined? Yes, it's here. OK, I was lucky enough to put a note. How smart of me. OK, now it should really work. Yes, it is deploying. And we can see it now running on a device. Let's select an image. We are coming back to the application, and look how fast it was. Two images blended together. Unfortunately, as you can see, the image that was added to the image is really covering the entire area. So that's a limitation of the 1.0 release of the API. Starting with 1.2, we actually do better. So let's try to modify a bit the behavior. Oops, I should stop the debug. Let's modify the behavior of the blend filter by specifying where the, oops. Specifying where the image should be actually positioned. And I do this with specifying the target area of the foreground image. And then I can also specify some more options, like to preserve the aspect ratio, for example. And let's see how this now behaves. OK, I select, again, the original image. And yeah, with one line of code, I can now position a sticker on any image in any position I want. I can control the orientation, I can rotate it, I can move it in the image in any position and control its size. So I think it's clear from this piece of code, and I hope you can actually see it better than I think you can see it there on the screen. It's very easy, and you don't need to know a lot about graphics to start using this. The source objects are very easy to create. After that, you just add effects on the stack. Just make sure that each effect receives a source, and then the output of that effect is passed to another component, which could be an effect or could be the final renderer to create the output. And if you want to add a new effect or one more effect to the pipeline, just say, for example, adding my custom effect here, a new custom effect, which will take now as a source the output from the previous effect. Okay. And then the renderers will have to work and generate output from the new end of the pipeline. So custom effect here, custom effect. One line of code, and I added one more effect to the pipeline, creating even more complexity on the pipeline, but also kind of altering the output towards the desired effect. OK. Let's return to the slides. Starting with version 1.1 of the SDK, as well as having support for big windows, we also added a very powerful component which allows you to interact with the user and allow the user to select areas of an image that they want to be modified versus areas of the image that they don't want to be modified. With very simple gestures, the user can annotate the image, highlighting areas which should be background, in this case the areas in blue, and areas which should be foreground, in this case the area kind of loosely annotated with red. The SDK is able to interpret those annotations and generate a mask out of that annotation based on the content of the image. And then using that mask, you can apply a filter only to the area of interest in the image, leaving the rest of the image untouched. For example, if you want to apply the lens blur effect, what you need to do is to just isolate the object in the foreground, say this object needs to be left alone, don't touch it, and instead blur everything in the background. And then you obtain something like this. And we have a very quick demo for this effect. Oops, I should start it fresh, or rather just load the image again. OK, so I'm using the surface of Windows just to show you that, yes, I can create a Windows application here, and I have plenty of space to actually demonstrate all the intermediate stages through which the API works. In the first box on the top left of the screen, you have the original image. We are not going to touch it. Instead, on the next box on the top, we are going to draw some lines to annotate the image. So for example, in this case, I want to say that this area over here is background. You see that I'm already generating a bitmap, which I'm going to feed as an annotation to the foreground segmenter effect. So the image that you see on the bottom left is what the effect will receive as an input. It's basically what I'm drawing on the canvas, just render it clearly. So OK, this area as well should be background. And now let's annotate the foreground. I want this area to be foreground. You see how very quickly the API generates a mask which understands what I, as a user, really want to highlight in that application. It's isolating the foreground object pretty well. Of course, it's not perfect, so I can go and annotate some more. I have a foreground here, so this area is still foreground. it's already getting slightly better, but I want to improve. So I say, OK, this is definitely background. You see how fast the API adapts to my annotations. It generates the mask, and then the mask is used to apply the bokeh effect, the lens blur filter on the image. And it's practically instantaneous. As you can imagine, the source code for this project is pretty much the same as in the previous project. You have the same source objects, the same filter objects added into a pipeline, and just provide the right information as input to each of the filter, and then render the output on the other side. Okay. So in the in the version 1.2 of the SDK that we just released, we support, again, not to forget, we support Windows Phone 8.1. But we also support creating GIF files. We can create either animated files or static GIFs. And here you have a demo of a levitating object moving. It's probably some 10 files, 10 frames there just looping around. Very easy to create, and we will see how we do that. Well, what I want to highlight here is the image aligner API, which is actually used to create a good quality GIF renderer. Because whenever you take a burst of frames that you want to then animate, your hand will shake unavoidably. So as you can see on the left there, or actually in the right, or is it on the left when you look at it? Right? The image is really shaky. And if you look at the highlighted areas, you can see how the table kind of goes on and off in the picture. On the other side, you see the GIF as created after the image were processed by the image aligner filter. And the result is very, very stable. And we can see that actually at work. Yep. We switch the project to more demo effects. OK, so pretty much the same story as in previous, because the API is very easy to use and follows always the same patterns. First, I need to create the source images. And in this case, I'm loading some frames from my resources using the storage file image source. And I add them to a list. Then I feed the list of sources. In this case, the list is actually called sources. I'm very creative that way. And just say, OK, you aligner, use these sources and try to align them all to the very first one. After which I call the method align async, and I just wait for it to finish its job. The result of that should be a list of aligned sources, so frames which have been modified by the filter, slightly rotated, slightly cropped maybe to remove the areas which are moving and jumping around in the image. And then I can feed that list to the GIF renderer by simply saying, OK, your source is going to be this list of aligned sources. Insert a duration of 100 milliseconds between frames and loop infinitely. And then, as with any renderer, I just call the render async method, and that does the job. And we can see this on the device. Again, it's a very creative example application with a very nice UI. Sorry about that. So I just started. As you can see, it's really, really fast. So that's 20 frames to analyze and align, and it was done instantly. It takes a bit more time to generate the GIF file. But there you go. We have it generated. So let's check the output. We use the GIF viewer application from the store to just load the GIF and play it. It's a pretty nice, stable, I would say, animated GIF. And to convince you of that, let's have a look at the source images. I think I have them here. OK, it's actually here. So if you look at the source images, they were shaking quite a lot. But through the magic of the SDK, that was removed in basically no time at all. OK. I have to go back to the slides. This was the imaging SDK. The point of the presentation was to just show you that there's a lot of options and possibilities in the package, but it's also very, very easy to use. The components are easy to understand, I hope. They can be mixed together very easily. You just add more filters to a pipe and just render it at the end, and the result is going to be, most of the time, spectacular. Now, if you have any ideas about how to create a very good imaging application using this SDK, and how to create a very kind of innovative experience for the end users using it, please join the imaging competition we are running at Nokia Developer, the Imaginate mission. The prize for it is a trip to zero gravity, so it's really interesting experience, plus a lot of prizes offered by Develop and experience points and things like that. Check out the website and join the competition, please. Now, as you have probably heard in the announcements in the keynotes, we released a couple of devices, actually 3 of them, 3 new models. And one of the features they have in common is the sensor core. As usual, we are trying to make that available to developers so that you can also try it and use it and see whether it's something that you are interested in and it helps you with your application ideas. We are currently releasing these as a private beta, so it's not yet available for download. It's just a preview, and if you are really interested, please contact us. My colleagues are going to be at the door as you exit, scanning the badges. Please make sure that you specify that you are interested in getting access to this SDK, and we will contact you later with details. Now, let's see what this SDK is really all about. As we know, it's a current trend. The users want to know how were they spending the day, what were they doing, were they sleeping right or not, were they exercising enough or not, did they have the correct position as were they standing at the desk. There's many solutions out there, there's many products which are trying to answer these. We are trying to do it from the phone, so the Lumia phones will be the part of this quest to discover users' behavior and learn from it and then help improve users' life through it. The package contains a number of APIs, which include step counter, activity monitor, place monitor, and route tracker. We are going to see in the next slides what they actually do. What is important to understand is that all these features have a dependency on the hardware, so they only work if the required hardware is available on the phone. They also have a dependency on the operating system. So although some devices out there may already have the hardware, until the firmware for Windows Phone 8.1 is released on those devices, they will not be working. So basically, for you to try this at this moment, you will have to have the new devices, the newly announced devices, and that's one of the limitations for running this as a closed beta program. Then there's also a bit of a privacy concern with regards to using this data. We have to make sure that the user is in control. That's why there's a global setting which allows the user to turn off the feature. And you cannot influence that in any way other than provide a reminder to the user, please turn it on because I want to help you with something. But the user is still always in control, can turn off the feature from the settings, can also wipe the data collected by the API or by the sensors. So this to be clear from the beginning. There are some limitations coming with the package. Now, the APIs are all designed to following the same pattern. So to begin with, all of them are accessed the same way. So you would say get default async, call the get default async method on each of the API, and you get an instance of that API so that you can work with. But before you do that, and because of the issues that we discussed in the previous slide, you should always be smart and check whether the feature is actually supported on the device or not. If it's not supported, it's not a problem. You simply don't use it. Your application probably can do other things which are not depending on this, so it can still be useful to the user.
In that case, just hide away discreetly the features that are not going to be available and carry on with your application. If the feature is, however, critical to your application, you have to fail graciously and show some kind of message to the user that, sorry, the application is not compatible with your device, and so on. But you have the tool here to do that and control the experience. All the APIs return COM exceptions as error handling mechanism. And the APIs also provide, or the SDK provides an API to convert those errors into useful messages, or rather states, so that you understand what went wrong with the API. In particular, you have to remember that because of the privacy concerns, if the user turns off location acquisition, for example, in global settings, you will always get an error through this mechanism telling you that, well, the API cannot work without location. The same way, if the user turned off the entire feature, so the mobile data acquisition, the mobility API is turned off, okay, there's nothing you can do there, so you have to handle that error as well. And then, as you will see in the documentation, if you get access to the SDK, or when we publish it, it's very important each time you go with your application to the background to deactivate the API, calling deactivate async, and then when you're coming back to foreground to say activate async. There's a little bit of a problem there. If you don't do it, your application may crash, and actually it will happen. So it's really important to get that sanity code there as a default automatically. Okay, the step counter API, as you could easily imagine, it gives you numbers. It gives you information about how many steps the user has done in the specified amount of time. You can get readings with a granularity of 5 minutes. So every 5 minutes, the sensor on the phone is saving that data into a log. You can go back up to 10 days and figure out how many steps the user has done on all this time, or you can get instant readings from the API and get the current values for the counters. You get information about steps done while walking, steps done by running, and how much that activity actually, or how long that activity was actually taking place. You have then the activity monitor API, which is monitoring a couple of states. We have them listed there. The list may evolve in time. You can always query the API to see which of the states are currently being monitored and supported by the device and the firmware. But then you can subscribe to events related to the changes of these states. For example, if you are interested to know when the user starts running, you can subscribe to the event and get an event notification when that status changes. Or if you want to know when in the last 10 days the user has been running or walking or performing some other type of activity, you have that data going back 10 days at your disposal. The place monitor brings location into the picture. The SDK, or rather the sensor components, are running all the time on the phone, even when the device is in low power mode, so the battery is running out, everything gets turned down, but this sensor is running on a separate CPU, or rather dedicated processor that's running the sensors, and it's running all the time. It's very low energy, it doesn't really impact the battery, so we are able to collect this data all the time. So we know where the user spends his time, and we are collecting that information into lists, and classify the information so that we are trying to determine where the user home is, where the user workplace is, and we give you that information along with other places of interest, which could be some favorite places where the user goes frequently, like restaurants or cinemas or libraries, things like that. So you just use the API to query, get a list of places, or get a notification, an event when things are added to this list or removed from the list, or when the user is just entering the proximity of that place. It's not a very precise API. It's not using the GPS unless the GPS is already used by some other application. So we don't give you any guarantees that we can notify you in time that this is the place where the user is now and is this
a particular interesting place for the user, so hey, do something about it. We just give you the opportunity to query, figure out what those places may be, and then if you want to use more precise ways of determining when I'm approaching those places, you can use, for example, the geolocation and geofencing APIs from Windows and improve the experience that way. Then the route tracker gives you a bit more data. It's actually collecting information about where the user generally goes to, how long it stayed in a certain place, where it went after that. Again, it's collecting the data discretely in the background, as accurate as it can, but not very accurate. So we don't give any guarantee to the accuracy of the location information. So don't think about using this as a, let's say, sports tracker type application. It's not about that. It's more about determining patterns in movements, determining areas of interest or routes that the user may take daily, and points on that route that could be of interest. And you can see in this image, for example, what I've done in the last couple of days in this area. It's all over the place. I'm sure I haven't been to all those places, but generally speaking, this is the area of interest for me at this moment. OK, so demo time. The API is very easy to use. And with the examples that we just show you on the slides, and they are going to be part of the package, we show you also our suggested way of using it, which sometimes can help you with avoiding maybe some problems. Like I mentioned, for example, it's very important that you handle the visibility change event. So when your application goes to background, you deactivate the API. And the other way around, when you return to foreground, you activate the API so you can receive data again. And yes, here's how we do that. Very easy, of course. Just handle an event and act on it. You will see that most of the time we are calling the API through this utility function, and there's a very good reason for it. We are handling there all the possible error scenarios. So as discussed earlier, the API call may fail at any given time if the user disables location, for example, or if the user disables the entire API usage and it doesn't allow data to be collected. And we have here a sample of how you could remind the user to basically turn back the features on so that you can continue using the API. But that's, like I mentioned earlier, that's all you can do. You cannot force the change in any way. OK, so let's see from the top. In this application, as soon as the application is loaded, I'm trying to detect whether I support this feature or not. If the feature is supported, I initialize the component. And as said, I try to handle the errors at the same time. So activity monitor, get default async, the common initialization method for all the APIs. Once I have that object without any error, hopefully, I just subscribe to the events I want to monitor. So I want to know if the user is idle, stationary, walking, or running. And then simply subscribe to the event that will notify me when that state changes. I could also read the current value so that I already have some information in the application. And it's as easy as calling the getCurrentReading async. And I get back a reading which contains the activity that's currently happening and the timestamp when that reading was done. And what I can do also is read the history. So each API offers data back 10 days, unless the user cleared that data for privacy reasons. So already, at the moment I install the application, there's a high chance that my phone has already data about the activities of the user or the behavior and patterns that on the behavior of the user for the past 10 days. And I can access that by calling the getActivityAsync method, getActivityHistoryAsync in this case. I can just specify how long in the past I should look and for how long in that time interval.
And if everything goes well and the API is actually enabled, I get the data back. And then in this case, well, I just parse all the history data, compare the timestamps, and determine how long a certain event took place. And in the application, I will create a graph with that. So very simple API. And let's see if it actually works. OK, things are being deployed. Oh, that doesn't look good. Something is not exactly working with the deployment. Luckily, I do have the application here. And by the time I start it, maybe the Visual Studio will kill it. But OK, here's the application. Currently, I'm not doing much with the device. It says that I'm stationary. I can maybe try to shake it a bit and simulate walking. It works better. The algorithms are designed to work when the phone is in the pocket. So if you do things like this, you may get false negatives or positives, depending on how you look at them. OK, I'm walking already. And as you can see, in the past, I've been idle a lot. So the phone was sitting there doing nothing, as you would expect in this type of event. But I've been also walking a bit around. So yes, I've done some things that the API measured. So this is one very simple example of how the API would be used, the type of data that it's able to provide for this particular case of activity monitor. How you use that data, that's something that we want to hear from you. And if you're having an application which would benefit from having access to this information, we want to hear from you and maybe get you access to the beta program so you can try it out. Here's how the step counter looks like. As you would expect, just numbers. And it doesn't help if I do steps like this with a cable connected, but it may actually at some point start increasing. No, it doesn't want to. The API is actually trying to avoid false measurements. So you will not see steps whenever you start taking steps. It's going to take at least 10 seconds for the API to start processing and make sure that you're actually walking and it's not some noise coming from your pocket or something. And then you start receiving the data. Let's see if the places shows me something. Oh, I have some static on the phone. OK, it still shows me that my home is in Finland, which is very true. Let's see if it knows where my work is. Yes, that's where the Nokia office is. I don't know what's happening on the screen when I do this, but yes, apparently there are some things where I'm frequently going, and I think this is over here somewhere. Oh, something is not right with this control when I'm using TV out, apparently. OK, let's see if the tracks are able to show me some history of my recent activity. For some reason, TV out and this component doesn't quite work. Yeah, so for some reason, GPS now thinks that I'm in Atlanta, so that's a bit of a problem. But yeah, I've been flying from Europe to San Francisco, and I'm sure in San Francisco I've been doing a lot of things that are being tracked. Yes, there's a lot of routes there. Most of them, I guess, around this place. OK, so as you can see, the API is very simple, it's effective, and it tries to collect data which is relevant to me as a user, help me discover myself, keep track of my activities, and then if your application can do something useful with this data, we want to hear from it and want to see it in action. The devices it supports, the recently announced devices, there may be some others in the future as soon as we release and update the firmware on them. So keep looking for news from our side regarding that. As mentioned, if you want to join the program, ooh, that doesn't look good. If you want to join the program and try this API and give us feedback about how we can improve it or whether the type of data that we are giving to you is useful or not, please let my colleague Leticia, who's going to be at the door, let her know about this, and we are going to be in touch.
And closing up, I want to remind you about the develop program. How many of you know what develop is? A few? Yeah, quite a few. We are running a program which encourages you as a developer to be active and keep developing your application, improve it. It's a frequent flyer program, if you want, for developers. You register your application, continue developing on it, let us know about your progress, and we give you points for that activity. Points that you can use for whatever rewards you want. You can get devices, accessories, Nokia products most of the time, but from other partners as well. You can get APIs, you can get tools, licenses, of course, for those, by just paying with your experience points, or basically points that you accumulated by just developing applications. It's a very good way to get rewards for your already done work. But let me tell you a trick that maybe it's not very well known by the develop users. With those points, instead of buying gadgets, you can buy promotional campaigns for your application so that it becomes even more successful, more visible to the user, gets more downloads, which then gives you more points from the develop program, and so on and so on. So please join in, check out develop.com, sign in, and then let us know about your applications and about your progress there. And thank you. That's all from me. If you have any questions, I'm happy to answer, or at least try to. Yes, please.
Here in the United States, we're not destined to get the 930 anytime soon. What's kind of the first that we might see firmware updates under the developer program or the like, so that we can actually test both the imaging and the location?
Yeah, as we know, Microsoft announced that there's going to be a preview release for Windows 8.1. Unfortunately, the preview is not enough. So even for existing devices which have this hardware capability, you have to wait for the official firmware release from Nokia, which will be in the coming months, but there will be no special release for developers, unfortunately. So, yeah.
Which devices would likely have the first firmware upgrades?
I cannot give you...
Just a guess.
Well, let's put it this way. There's only 2 devices out there in the market which have the hardware support to begin with, but those devices should get it at the same time as everybody else, or all the other devices, more or less. So the devices you should be looking for are the Lumia Icon and the 1520.
Okay, thanks.
Oh, and I forgot to say, we have more T-shirts. If you don't have a T-shirt, you're welcome to come pick one up. Any other questions? Yes, please.
Which of the SDKs work with the 2520 tablet?
The imaging SDK does support Windows. We've seen a demo running on Windows, on the big Windows, so that one you can use. The sensor core is not available on the tablet.
And I think you also have one for Mix. Is that right?
Sorry?
Mix Music?
The mixed music, definitely, yeah,
Okay.
It does.
I also had a question not about SDK. I noticed in the MSDN documentation, Windows devices, what is it? Windows devices. I'm sorry, I'm forgetting what it is. Wi-Fi Direct.
Okay.
Windows devices, Wi-Fi Direct. SDK or MSDN documentation says that it's supported for Windows Phone 8.1. And I'm wondering, are there any Nokia devices where Wi-Fi Direct will actually be supported?
I avoided that really quickly. Wi-Fi Direct, I really cannot comment on that. I don't know how the updates to the devices are going to change the availability of that feature, because it's not only software as far as I know. So, sorry, I cannot give you any info on that.
Hi, I'm going to ask you a question I've asked other people today, the same question, so I'm going to ask you the same one. In the SDKs for imaging from Microsoft and from Nokia, there is one area which is lacking, and that is being able to access the extended data on the images.
The EXIF.
Yes. We need an SDK that we can be able to read back the information and write additional information, or because you only store longitude, latitude, altitude, camera focal length, and bounding boxes, but we cannot grab that information correctly. We can't even grab the GUID, which is the name of the image, because if they rename it, if I save off an XML file of what I need, I can't get back there.
Yeah, I understand your problem. And actually, we recently discovered a problem with accessing some of the images captured by the Microsoft camera versus the images captured by the Nokia camera. They save the data slightly different. And then when you try to load them, there are some issues there. We understand that there is a need for EXIF, from our point of view, at least for read, so that we're able to solve that problem that I was just mentioning. I think we are going to try to figure out if we can put it to be part of the imaging SDK. We can add it to the list of requirements, see if we can add it to the package. There are some third-party components out there. At least I remember using the read part. Probably not completely solving your problem.
The open source ones work fine on 7.1, but it broke on a Windows Phone 8.
Oh.
So yeah, it got complicated, and so I was just curious if you, I hope you will pursue this, because it's extremely information to be able to package everything in one spot.
Yeah. Like I said, we are going to put that on the list, and hopefully it's going to be in the next release of the imaging SDK. It's not a promise, it's just a wish that I have now. So,
are you going to consider in the future for the Nokia cameras or the Microsoft cameras, whatever the company finally becomes, of actually putting something in there like the kinetic sensors to actually do depth perception measurements across the same point of field?
yeah, again, something I cannot comment on. I'm sorry. If something like that will be possible, I'm sure the imaging SDK will have something to help you with
I
that.
will be scanning my tag over there, yes.
Okay.
Sorry for my second question, but one of the, of course, very unique things about the Nokia camera is you can access the raw information, the DNG filing. Is the capability of accessing the raw or the DNG something that's going to be opened up in the imaging SDK? Because I think that it's not.
Well, the imaging SDK does not support the format, and I think in general on the phone, no application supports the format as such. So we save it, but then we assume that the user will take it to the PC for further processing. So as far as I know, we don't have yet an efficient way to actually manipulate that file.
Going back to kind of the raw information there's the Microsoft APIs that allow you to have bursts of pictures and the like. Is my understanding correct that that's not available for the highest resolutions, the 20 megapixel or the 40 megapixel?
I haven't yet tried the API, and definitely didn't try it with 8.1 on Lumia 1020 to see how it behaves with the high resolution.
Or the 20 megs on the 1520 or the...
Yeah, the Lumia 1020 is the reference point, right? So if it works with that one, it works with everything.
Okay.
But I don't know yet. So that will be something that we definitely are going to look into, and there will be example published, because the GIF renderer and the ability to create animated GIFs relies on having this burst and be able to capture the frames. Now, one other thing that you want to know is that, okay, you capture those bursts in order to create a GIF. You want the frames to be small so that the GIF is also small, because the higher resolution you go, the bigger the problem on the other side. So in a way, I'm happy if this burst working properly with low resolution, but I understand also maybe your need to have a full resolution capture. I need to look into that. I don't have a clear answer. Any other questions? We have T-shirts. Okay, I think one thing I forgot to mention is that my colleague over there is scanning your badge as you exit. So by simply being here at this presentation, you qualify for a raffle of some Lumia devices. So follow the Nokia developer account on Twitter, and tomorrow you should hear some news about that. If you are lucky, it could be good news for you. Thank you.